Right, so let's take a look at example 1 in concept 1. So example 1, earlier you were given a problem about Tammy and her ice cream cones. She wants to record the information from her table. So what I'm going to do on my notes page is I'm going to draw a line just to kind of divide the fact that we are all done looking at definitions. And we're now going to start examples. So I'm going to title this as example 1. So in this example problem, it says that we're making a list of the ordered pairs represented by the table. So if we go back up to this table from the beginning of the problem, we have the days in operations and the number of cones sold. So we can set this up in making our list of ordered pairs. The first one, where the first number is the days in operation. So when she was in 1 day of operation, she sold 48 cones. So 1, 48 would be the ordered pair to represent that. Then we have 256. Then we have 377. Then we have 479. Then we have 582. And then 698. And last 7 and 105. Keeping in mind that the first number in all of these ordered pairs is representing the days in operation, which would be your X values, and the second number is number of cones sold. So moving back down to example 1 in the textbook, it says next look at the ordered pairs to see if any X and Y, or to see if any X value is paired with more than one Y value. Because what we're trying to figure out is, 1, what is the domain? Or what are the X values in the sets of ordered pairs, and then what is the range, and then also thinking about, does this set of ordered pairs represent a function? Okay, so first let's get practice writing domain. So I'm going to write the domain for this set of ordered pairs. Domain is all of your input or all of your X values, all of these first numbers are written. So I'm going to highlight them in the ordered pair. So all of those first numbers in the ordered pairs representing our domain. So I'm going to write them out. And if you ever have any repeats, you don't have to write them multiple times. You can just write it once. So my domain is all the numbers 1, 2, 3, 4, 5, 6, and 7. And I'm going to put some squiggly brackets around it. You don't have to. It's just more mathematically correct, I guess, using proper math notation, but I won't mark you down if you don't have the brackets, okay? Next, let's write down all the numbers that represent our range. Remember, range is all of our output values, all the numbers that we get out, and they're all these second values. So our range is all of these second numbers in here. So 48, 56, 77, 79, 82, 98, and 105. So I'm going to write those out in a list. So 48, 56, 77, 79, 82, 98, and 105. So if a problem is asking you to identify the domain and range of a set of ordered pairs, your domain is going to be the list of all the X values, or all the first numbers. Your range is going to be the list of all the Y values, or all the second numbers. Now what we want to do is we want to determine, is this a function? We want to answer this question, does the order set represent a function? In order to identify if it represents a function, we want to look and see, do all of the X values pair with one unique Y value? Well, all of our X values only occur once in all of these ordered pairs, and they're all being linked to their own unique Y value. So we're going to say, yes, this is a function. Every X value has its own Y value. All right, and that's going to wrap up example 1.